I've gone and downloaded Google search data for motivation over 5 years for 6 different countries in the world, linked it all up together so we have one big data set that shows for each of these countries how motivation changes over time. But we still have a problem because we don't know whether the US 100 is higher or lower than the UK 100 and how to compare across different countries. My first attempt at how to do this fell a little bit flat, so let's talk about it. So when I started this project, I wasn't the connoisseur of Google Trends that I've become now. And so I went and I typed motivation into the search bar and it defaulted to UK because that's where I am. And then I was like, great, now I can compare it to the US. So I opened that comparison tab and I typed in motivation again. And then I switched the country to the US and was like, oh, that's really interesting. The searches are kind of about the same. It wasn't until I got to China that I realized that the country thing was changing the entire graph and all I was doing was just loading the graph for the country I was searching for 4 times. So if I can't get the countries on the same graph, then I can't compare them. Unless I come up with a more creative way to do it. My next brainwave came from when I was looking at the US, because I noticed if you scroll down to the section below, you'll see that it can show you relative volumes for the different states. So I thought, well, if I can do that for states, why not do that for countries? And I switched it to worldwide and I saw, okay, US has a certain score, UK has a certain score. Maybe I can compare the two and use that to scale my data. But actually, there's a bit of a pitfall here, and this oversimplification almost ruined my entire project. I'm going to explain why, but I'm sorry, I'm going to have to use some maths to do it. So I grabbed 90 days worth of data starting at the 24th of April for the UK and the US, and I have them on 2 different graphs. As you can see here, the 100 score, the maximum Google Trends score, is in a different place for each. Hey, Badoof, get back inside the basket. The problem is that because we're looking at 2 different countries, the Google Trends data for each are in fundamentally different units. Just like inches and centimeters, both measure distance, but in very different units. And unlike inches to centimeters, we don't know what the conversion factor is. This is the most complicated part in the entire video, so let's bring in some numbers here. Let's assume on the worldwide graph, the US is given a Google Trends score of 100 and the UK is given a Google Trends score of 50. This means that the peak of UK searches is 50% of the peak of US searches. So my initial assumption is that I could just halve the UK graph to scale it all down, and that would work and the two would be comparable. I'm now going to convince you why that doesn't work. Let's take a day that is not a peak day, 30th of April, for example. And let's say hypothetically that the Google Trends score was 70 on the 30th of April in the US and 80 in the UK. Now that means that on the 30th of April, the search volumes were 70% of the peak search volumes in the US on that day, and they were 80% of the peak UK search volumes on that day, where peak is defined to that period. So if we go with our example from earlier, where US peak was 100, UK peak was 50, and therefore 1 US trend unit was equal to 2 UK trend unit, the maths looks a little bit like this. 70% of the US peak is 70% times 100 US units. That's 70% times 2 times 100 UK units based on our scaling factor there, and that's equal to 140 UK units. And now looking at it from a UK perspective, 80% of the UK peak is 80% of 100 UK units, which is equal to 80 UK units. Last time I checked, 140 was not double 80. Just because the US peak is twice the UK peak does not mean that the entire US dataset is twice the entire UK dataset. So, okay, we can't just take the worldwide ratios and apply them to the data to be able to compare countries. Well, what can we do? Well, that's why I have this. The thing I love the most about data science is that its underlying science and methodologies can be transferred across loads of different domains. For example, a few weeks ago, I used an algorithm designed in computer science to optimize Bart Simpson's trick-or-treating route around Springfield. And for this problem, I'm going to do something similar. Because I learned my data science skills long before I ever knew what a data scientist was, forged on the trading floors of an investment bank. If you know the term exchange traded fund, then you might have a little bit of an idea of what we're in for, but if not, do not fear, I'll explain everything. Next week, I'm going to be breaking down how a financial product invented in 1989 can be used to answer this real-world problem of how do we compare Google Trends data across countries. It has uses in marketing, entrepreneurship, academia, and general curiosity about how the human mind works. So if you're finding this data science deep dive helpful, then hit subscribe so you don't miss our next video on the topic. We're all about breaking down these complex data science topics in ways that you can actually go and do this yourself. So if you have any ideas, let us know in the comments. Oh, and one more thing for today. Data science is always more fun if you let yourselves be a little bit evil.